Welcome to our breakout session, Responding to Cloud Incidents, Tales from the Front Lines. I'm very excited to present this today. This has been well over a year in the making. Usually when I come up and do these talks, I'm talking about cloud security, container security, but I really thought it would be very important for people to understand what happens behind the scenes. CrowdStrike, you may be familiar with our Falcon platform, but the first product that CrowdStrike offered to the public was incident response. And incident response and threat detection underpin the effectiveness of our platform, as we'll talk about today. My name is Rob Solomon. I am Senior Solutions Architect at CrowdStrike for the AWS Partnership and a former AWS SA. I'm glad to be back on the stage. And I'm joined by my colleague.
Hi everyone, my name is Mariah Kenny. I'm a senior incident response consultant with CrowdStrike. I've been with CrowdStrike just over 6 years now, and I've been doing incident response for the last 5, and then I specialize specifically in cloud security.
Yay, it's working. There we go. So we're going to talk a little bit about the threat landscape, current state of cloud security. Then we're going to talk about the adversary tactics and how to prepare so you can avoid being in the headlines. And then we're going to talk about how CrowdStrike helps you stay secure in the cloud. It really starts with, as usual, working backward from the customer. Our customers are, thank you. Our customers are telling us that they're struggling with their security solutions, that the attacks that they're seeing are more sophisticated, more stealthy, and faster, and we'll see that there's a lot of data to back that up. Also, customers have a lot of different point products and rising expenses between those products and integrating the products. There's a lot of time and effort spent taking all of those different point products, those different siloed products, correlating that data, bringing it together to drive detection. So it's a difficult environment, and customers are asking, how can we make it more simple? And this really reflects what we're seeing in terms of threat landscape. 90% of all enterprises are multi-cloud, not just one cloud, not just in the data center, hybrid environments, highly complex environments that span geographic areas. We're seeing an expansion of the attack surface represented by customers being in the cloud, where we've seen a 110% over the past year, 100% increase in cloud-conscious attacks. And what that means is that the attacker, the adversary, they're aware that resources that they're attacking are in the cloud environment, and they understand enough about those cloud services to know how to exploit them specifically. And then beyond that, 75% of attacks on cloud resources, sometimes the adversary knows that it's the cloud, sometimes these are cloud agnostic attacks. Now, we keep seeing this number year after year, where 8 out of 10 attacks have this identity component where the attack, and in general, attacks start with gaining that initial access. It's not that complicated. The attackers start by identifying the target. They go to the dark web, and there are businesses built on selling stolen credentials, stolen or compromised credentials. So an adversary can decide, okay, I want to attack this company. Hey, does anybody have any valid credentials? Even better if they're admin level or root level credentials. So they're just walking right in the front door, and those attacks are even harder to detect. The attacks are gaining speed. The fastest we've ever seen, 2 minutes and 7 seconds. Yes, how do you protect against an attack that moves so quickly? Clearly you want to have that defense in-depth strategy. On average, the attacks are 62, 64 minutes on average. And year over year, we see that average time to its lateral movement, breakout time. So after the initial attack, the time it takes for the adversary to move into the environment for data filtration, gaining persistence across other resources, again, 62 minutes. And year over year, we see that decreasing by about 10 minutes. So they're getting faster. Finally, the attacks are sophisticated. You know, back in the day, everybody was worried about malware, and obviously still you need to protect against malware, but those malware attacks only represent about 25% of attacks. The remaining 73-75% are interactive, where the adversary is hands-on keyboard, they are doing manual reconnaissance, they're adapting to the conditions that they find once they log in, so they're able to counter the measures that they find in place to find the path of least resistance. So here's an example of an attack that we observed during an incident response. So, you know, in the top, we see the different stages in the attack. Again, starting with gaining legit credentials. How does that happen? I'm just going to my friendly dark web storefront, buy those credentials, and now I'm ready. So, log in, download or drop additional files. What we're finding is the attackers are increasingly using valid files, either native to the OS or common packages that are not going to trigger a malware alert or anything like that. So in this particular case, what we see is a Discover tool was dropped. The EDR solution alerted in the console, looks like the attack was blocked. Security team stands down, goes on its merry way. The attack doesn't stop there though. Because the attacker logged on with valid credentials, they're able to log onto the console. They do an LSAS dump. They have access to Active Directory. They're able to create their own federated Active Directory, and they get to lateral movement in 62 minutes. Meanwhile, SOC analyst is reviewing the alert. About 4 hours. Now, your mileage may vary, but in my experience, security teams are very busy handling a barrage of alerts and having to investigate each one. And then after that initial analysis, it can get escalated to additional teams, threat hunting, incident response, forensics teams. But this attack has already run its course before it's even really being looked at. We're going to come back to that example toward the end of the session. So again, adversaries are breaking in and moving laterally in 62 minutes. Security teams are identifying an intrusion on average 204 days. So you hear about advanced persistent threat living off the land. That's what we're seeing. When we come in to do an incident response, we're often finding that the adversary has made themselves comfortable in your environment. Now, how do you solve this problem? What a lot of teams will do is, okay, we want to catch these, so we're gonna tighten up our policies so we catch things earlier. And so we want to create those more strict policies. Okay, you can do that, but now you're going to block more of normal IT processes, increasing alert volume. You've got the security team already overburdened, now checking like a much larger number of alerts and disrupting business operations. Or you can say, well, all these alerts are bringing us to our knees. We're going to lighten the load a little bit, create a little more lenient policies. But now there's a sort of level of uncertainty. Am I catching things? There's going to be more manual intervention to make sure everything's okay. And it's going to delay the ability to respond and research different alerts. And either way, you're missing potential intrusions. Now, the scariest thing that I learned preparing for this talk is that up to 60% of advanced intrusions are undetected by autonomous solutions. So, obviously automation is critical to driving speed and expanding the capabilities of human investigators, but autonomous only is missing these sophisticated interactive hands-on keyboard attacks. Now we're gonna get a little bit more into the details, and Mariah's gonna talk about tales from the front lines.
All right, so now we're going to talk about the evolution of adversary tactics and techniques. And in other words, how are these unauthorized entities accessing cloud environments, and what objectives are they trying to achieve? So on the left here, you see a number of different initial access methods that we've observed. And all of the things that I'm going to be talking about in the next few sections here are based on about 20 cases that I've worked on or had visibility into over the past few years, and then focusing obviously on tactics that we've seen most recently. There are some tactics that continue to be successful, that attackers have been using for years, and then there's some new tactics as well. Like Rob was saying, initial access through valid accounts is a very, very common vector, whether those credentials were obtained from an underground forum or obtained through phishing, or if there was some sort of on-premise compromise within the environment and there were plain text credentials or keys on a particular workstation, and the adversary was able to harvest those credentials and then leverage them to pivot to the cloud. So again, valid credentials, common initial access method there. We have also observed credential resets and then MFA bypasses as well. So something what we've seen an uptick in recently is actually threat actors reaching out to help desks, impersonating an employee of the organization, and saying, "Hey, I forgot my password. Can you help me change my password?" And they might, help desk will typically have identity validation questions, but those questions, depending on what they are, might not be as rigorous. It might be based on information that the adversary can find publicly available. If it's just confirming your date of birth, or some other piece of information that they were able to obtain from some other data leak or something like that, where they can then answer those identity validation questions correctly, and then the help desk will help them reset their password. We've also seen that threat actors will go a step further. So, they get their password reset, but they said, "Hey, I lost my phone. I got a new phone. Can you help me reset my MFA?" And so then the, help desk again will go through and assist that adversary impersonating an employee to attach a new MFA device to their account, basically granting that threat actor access to the environment with MFA, but because it's a threat actor controlled device, they can obviously authenticate themselves to the environment. So we've seen that as well. We also see some MFA bypasses through the theft of sessions or cookies as well within the cloud environment. Again, depending on if there's a specific endpoint that was compromised, and that is a developer's laptop, and they've been using that system to access other resources, the threat actor can use those same access avenues to pivot to the cloud. We continue to see abuse of public-facing applications. Whether that's hosted on-premise or it's hosted in the cloud, it's going to continue to be a target for adversaries. Whether they're brute forcing, password spraying, they have valid account or valid credentials to the application, or if there's some sort of vulnerability in that security stack there.
Patch your applications.
Yes, absolutely. And then exploitation of misconfigurations as well. Of course, this has been an issue previously. It will continue to be. Historically, it might have been something as simple as like an S3 bucket that was public. Obviously, there's different security controls in play now, and we have improved from that perspective. But there's always going to be new resources, new services, and different ways that those are set up depending on your organization, and something that potentially is configured properly for the use, but an adversary will maliciously leverage that feature for their own benefit. We see a number of different motivations and different objectives that adversaries are trying to achieve. A majority of the cloud intrusions that we're seeing, whether they're aware that the infrastructure that they've compromised is actually in the cloud or not, it's primarily e-crime. So actors that are trying to monetize their access to your environment. We also see targeted intrusions as well, but primarily what I'm going to be talking about here is e-crime. But of the different adversaries and varying sophistications, three main targets that we see: access to data. So for e-crime, being able to successfully exfiltrate data from the environment gives them a really good opportunity to monetize that access, to basically hold that data for ransom or extort the organization. Say, hey, pay us this amount of money, or we will post this data publicly. And we have seen, sometimes they'll do it in piecemeal. Of course, it just depends on the adversary. We'll continue to see, access to compute resources being a target as well for typical crypto mining operations, and then access to other targets as well. So whether that is an actor that, again, started on premise and was able to pivot to the cloud, or if they have access to a cloud environment that then has other tie-ins to other infrastructure, whether that's within the same organization, or if you're an organization that then obviously offices services for other organizations and there's an access avenue there as well, that actors will leverage that as well. So another way of talking about this, is initial access methods and then their motivation. So what we're going to be talking about here is what happens in the middle. What are adversaries actually doing to, once they've gained that initial access to the environment, what are they doing to actually achieve their objectives? The first thing that we typically see cloud threat actors doing is discovery. They've gained access to this credential, by whatever means they gained access to this credential or access to the environment, whether that's through a credential or through a system. The first thing they need to do is figure out what they have access to. Let's say that it is a compromised key. What permissions are attached to that key? What services might they be trying to target? If they're trying to exfiltrate data, they might be looking for S3 permissions, RDS permissions. It just depends, again, on what their objective is. But regardless, they're going to have to figure out what's in the environment and what they have access to. Now, we typically see discovery, there's a number of different API commands. Typically, we're looking at list, describe, and get API commands. So again, if they're potentially looking at S3, we'll see them. And these are API commands that we've observed in investigations that threat actors have run as part of their discovery. So listing objects, and again, if they're targeting EC2 or RDS, we also see enumeration of some of the other services as well. Again, just figuring out if they're trying to go after specific data, or maybe they're just trying to figure out what permissions they have. If they have a longer term objective and they're actually trying to establish persistence in the environment, they might spend more time kind of figuring out the naming conventions for the roles and policies and things like that, so they can kind of blend in. Similarly, on the identity side, we see a number of other API commands that are issued as well. Get caller identity, we'll come back to that one here in a minute. There are some tools, that will use that to kind of validate the credentials, but we also see threat actors running it just to understand, again, the context of the identity that they have access to and what they can do with that identity. And then enumeration as well of, what policies are attached to that identity and what access it might have. All right, so once the threat actor has done their discovery, they kind of figure out these are some different targets that we might want to go after, or they've found, that a number of those API calls that they made were actually unsuccessful because they didn't have the permissions to make those calls. And so we might see that they might go after credentials instead. So typically, we might see EC2 and then secrets manager access as well. Get secret value where you're just pulling one secret, or batch get secret value where you're pulling the whole set of secrets. Keep in mind, that these API calls are going to be, region-based. And so if your main operating regions are US East 1 and US West 2, and, you might see these calls there. But for some of the other enumeration commands as well, you might see those across other regions, even non-operating regions. Again, if, the adversary is trying to get to know your environment, they might not know your, operating regions. And so they'll have to kind of do that discovery to figure that out for themselves. All right, so, let's say that they were either able to successfully access those credentials or they were unsuccessful, and again, depending on that initial identity that they had access to, what permissions might be attached, they might need to do some sort of privilege escalation. So two common things that we see with privilege escalation is actually either attach role policy or attach user policy. So they've done that enumeration of the different resources within the account, subscription, or in this case, we're talking about AWS. But if those additional permissions that they need are not attached to the identity, they might attempt to attach those additional permissions themselves. All right, so the threat actor has already gained initial access. They've done their initial discovery, figure out what's in the account. They might have attempted to access additional credentials, or if that initial identity is privileged, they might not need to do some of these other steps, but let's assume that they needed to. And they have a longer term objective. They're actually trying to maintain persistence within the environment for a longer period of time, potentially for longer term data gathering. Again, it depends on the adversary's objective and your environment and what might be of interest. But here are a number of the different ways that we have seen threat actors try to establish persistence. In some cases, it can be a little bit stealthier, where these actually happen over days, weeks, months, where they've tested their initial credential, they have some of that information, and they might come back and then do some additional discovery, enumeration, or establishing persistence. In other cases, this all happened, like Rob was saying, within that first hour, where they just run all of the things and see what they get back. So it really just depends. But creating an additional user, creating an additional access key, establishing that additional persistence within the environment. So if their initial, say, API key that they were using for access was rotated, and they no longer have access to the source where they got that initial credential, they might have these alternative methods to maintain persistence within the environment. All right, so going to exfiltration. Now, before I kind of get into this, there's a number of different ways that data can be exfiltrated from a cloud environment. There's a number of different ways that a cloud environment can be compromised. It could have been a control plane compromised, where there is identity that was compromised, and we're seeing these API calls. But it might have been a web application where that infrastructure, is hosted in the cloud, but all of those calls are made through the application itself. So you're not always going to necessarily see exfiltration from a cloud environment at the control plane level. It depends on how that data was accessed. If they're making a query request to a database and those calls are coming through the application rather than at the control plane level, and they're not necessarily accessing a database instance directly, you might not see visibility at the control plane level. So the most common thing that we do see at the control plane level is S3 get object, so exfiltration from an S3 bucket. Whether that initial credential that was compromised was, had S3 permissions and they were able to do that directly, or if they took the steps through these different privilege escalation methods and were able to attach a more privileged policy to the identity and then successfully exfiltrate that data. All right, and kind of like I was saying, an adversary is only going to do as much work as they need to achieve their objectives. They're not going to just unnecessarily make all these additional API calls, make all this additional noise if they don't need to. Obviously, from a security perspective, any kind of roadblocks that you could put in the way for an adversary is important, because they will have to take those extra steps. They will potentially generate some more noise, and that gives you a better opportunity for detection along the attack path, because obviously we want to detect this earlier on rather than after the exfiltration's already happened. So that being said, let's say that initial identity that was compromised, they do their discovery. It is a privileged, permanent credential in the environment, and so they're able to just move directly to exfiltration. If that initial identity already has all the permissions they need, they might not take all of those all of those steps in between because they don't need to. They have the permissions they need, they access the data they wanted, they exfiltrated it, and then again, they might hold that data for ransom or attempt to just sell it directly on underground forums. All right, that being said, that's what an adversary is doing on their side, but what can you do on your side to actually prepare for incident response? A few fundamentals here for response. People, tech, and process, they're all very important. This is obviously focused more on tech, but I think it is really important to look at it holistically and understand in an incident what it really looks like, and that it is a team effort. It's not an individual effort. It's not a race to see who can find what first. It's working together against an adversary that has unauthorized access to your environment to attempt to contain, remediate that activity, and then do the retroactive investigation. So from a technology standpoint, obviously, whatever your stack looks like, all of you all are going to have different environments. You're going to have different security stacks. But hopefully there are some detection capabilities within that environment, so you are aware if an incident does happen, so that you can actually engage your response capabilities. But to do that, you would need to know that something occurred in the first place. Also, having logging available is obviously very important. If you go to do an investigation and there's no logs, it's hard to say what happened. And an adversary, let's say that they did establish persistence within your environment, but you didn't have the logs to actually identify that activity, they could maintain persistence within your environment for a longer period of time and continue operating within that environment. And then obviously security controls as well. So from the people side, I kind of want to talk about, so I'm an incident response consultant. So my day-to-day is I'm either managing projects for incident response or I'm conducting analysis. And so, we've responded to a lot of incidents and we've seen a lot of themes and, things that teams are doing really well and things that teams could do to improve. The main thing that really ties it all together is communication. Making sure that you're all on the same page, that you know who's in charge of what, and that you have some sort of flow there. Obviously, the security team is going to be involved in an investigation, or I would hope so, to actually initiate that response. But let's say that you got a notification that there was a database that was posted of yours on Underground Forum. And so then you get this information and you're now going to do an investigation, right? So you don't have necessarily, a full picture of what happened, but you're going to do that investigation. Let's say that you do that and you've identified that there's actually additional credentials that were exposed or compromised as part of this as well. So it kind of, it expands past the security team. Now you potentially have an application team kind of understanding, what logs might be available from that application, how those credentials rotating those credentials, and then understanding what the additional potential data exposure there is there. Then, legal gets involved. If there is some sort of data exfiltration or exposure, what kind of data was it? Kind of getting either your internal legal team involved, if you have to get external counsel involved, making sure that you're all on the same page on what your priorities are in the investigation. And that you're talking to each other about what you're doing. So you're not all just looking at the same thing, you're actually making sure that all aspects of the investigation are covered, because one of the priorities is getting visibility during an investigation, making sure you have full visibility into your environment in the first place. You can't defend what you don't know about. And then making sure that once you do have that visibility, you understand what the threat actor was actually able to do within your environment to know what that blast radius is, what that impact is, to understand who else you might need to get involved. And then, depending on what stage that is, if there was successful data exfiltration, if there is PII or some other sensitive data that was included as that exfiltration, are there additional communications that need to happen? What updates need to be routed up to the executive team so that, again, everybody is on board and everybody knows what's going on? And then, the thing that ties that all together is process. So again, coming back to containment and remediation. Once you have that visibility, into your environment and visibility into the fact that there is an incident that you are triaging, what does that containment and remediation process look like? Do you have a process for that? If there's a particular type of incident, if an EC2 instance is compromised, do you have a process to actually, preserve that evidence, potentially take a snapshot of that incident, of that instance? What's your triage process look like after that? And then, for a broader investigation, what log sources are you looking at? All of those things are important, but having a process, to kind of tie that all together so you don't get into a situation, you're like, I don't know what to do next. With at least a process, what the next step is. And even if you don't know what to do, at least know what the next person to talk to is. So, hey, something happened, who do I go to next? Because you might not know the answer, but they will. And if they don't, they know the next person to talk to figure out, what the next step is there.
When you're in the middle of an incident is not the time to figure out what your process is because everybody's freaking out at that moment.
Exactly. Have a process, but make sure you test it. I've also worked on some cloud red team, blue team exercises, which have been really valuable for organizations because they can actually test their incident response process without being in the middle of an incident. They can say, hey, these log sources that were being forwarded, we assumed they were being forwarded and they were being retained for 6 months. Turns out they're only being retained for 3 months. Or, we thought that these fields were being parsed out, but we went to actually go run the queries and they're not actually parsed out like we thought they were. Different things like that, kind of triaging that and getting all of those things sorted ahead of time. So like Rob said, you're not dealing with all of those things in the middle of an incident. All right, so let's talk about spiders and specifically spider webs. spiders will spin webs to catch food. And each of those webs is going to look different depending on your environment, depending on, where it is, what the conditions are, but it'll spin that web in hopes of catching food. And there's two main ways that a spider will monitor their web. They'll either sit in the middle of it and, physically watch and see if there's anything that runs into the web, or they might be next to the web, and leaves, whatever, kind of on the side, but they'll set a trip line, a thread that goes from the spider web to them. So if something hits that spider web, they'll know. In this case, our security is our web here. If something does hit your environment, something anomalous, suspicious, or malicious is able to reach your environment, would you know about it? So let's say that something does hit your environment, okay? There's unauthorized access to the environment. Of your security stack, is it going to notify you, or is that going to be the end? If there is, let's say that you have all these tooling and they are generating alerts, but if all of those alerts are staying within that same console and they're not being forwarded anywhere, they're not being forwarded to the security team, then they won't necessarily know about that. I've worked on a number of incidents where there was actually an alert that was generated prior to the organization being aware that an incident had occurred, but there is a large volume of alerts. There's varying levels of fidelity. There's varying levels of process and forwarding of those alerts for a security team to review. And kind of like Rob was saying, that can take time. There's a whole queue of things going on there. Alternatively, if something hits your environment, you want to have your trip line. You want to have something that is going to notify you that something occurred, whether that's a custom SIM alert, whether you're using Splunk, Datadog, whatever it is. Guard duty. If guard duty alerts are generated, those are pretty high fidelity alerts within AWS, but you want to make sure that those are actually being triaged. You don't want to find all of these alerts in guard duty after the fact, alerting you to this anomalous activity as it was happening. You want to know as it's happening, right? So that you can actually remediate that access before that adversary can actually reach their end objective. And if they're in that initial discovery phase, that we were talking about earlier, and you see that initial reconnaissance, maybe from an anomalous IP address, whatever it might be, whatever's flagged, you want to know about it earlier on so that you can cut off that access early on without letting that adversary get to the additional steps, without allowing them to establish persistence within the environment, without allowing them to actually successfully exfiltrate data. You want to know earlier on. But again, even if you have these alerts, you want to make sure they're actually being forwarded somewhere so that you can see them and so they can be triaged in time. There we go. All right. So now, how can you detect or prevent adversary activity? Something that I do want to cover, these different phases that we've talked through are mapped to the MITRE tactics. Not all cloud techniques have a direct mapping to a MITRE attack framework, the specific techniques themselves, but the overarching tactics are still really effective for understanding which stage of an attack an adversary might be within your environment. So kind of coming back to those, covering discovery here. Get caller identity. That was one of the discovery API calls that we're talking about. It's basically like a who am I, an adversary trying to understand the context of the identity that they're in. In this case, we have a tool here, in this case, a user agent, TruffleHog. We've seen an increase in use of TruffleHog in a number of cases recently, actually. TruffleHog is a credential scanner. You can run it against different code repositories. You can run it against an S3 bucket, different things like that. But basically what it does is it'll scan those repositories and it'll return any credentials that it identifies. So like an API key or something like that. And then what it'll actually do is then it has the option to validate those credentials. So if an adversary is able to gain access to GitHub repositories, through some sort of token, if there's some sort of supply chain attack that exposes tokens to GitHub, whatever that access method is, if they are able to get access to potentially internal GitHub repositories, they can run this tool against it. And the credential validation for AWS keys specifically is get caller identity. So if there are keys that are identified by TruffleHog, specifically in this case an AWS API key, you'll see a get caller identity call with the TruffleHog user agent. Specifically, some security teams do use TruffleHog legitimately within the organization to kind of do that scanning, credential scanning themselves. That being said, again, depends on your organization, but there's potentially, a ticket associated with that if they're running it, or if the process is not necessarily that developed within the organization. This is a good starting point to say, hey, who is running this within our organization? Is this authorized? Kind of keeping that list of, who might periodically run it. So if you see it run by an identity that's not expected, that would be more anomalous and warrant additional follow-up. All right, so looking at the credential access, and this is more logic query, I guess, rather than a specific, say, Splunk query or something like that. But in general, you're looking at this is for CloudTrail. All of these are for CloudTrail, and then you're looking at Secrets Manager, and then this event name star get secret value. So that would catch both the get secret value command and the batch get secret value for Secrets Manager. Again, these are legitimate API calls within AWS. So there are going to be identities that are leveraging these API calls as part of their normal function. The important part here is adding that additional filtering and kind of granularity based on your environment specifically, and kind of filtering out those expected identities. So building on this query to tailor it to your environment specifically, filtering out identities that you see this commonly from. And so, again, if you're seeing these API calls from an unexpected identity, that's a higher fidelity alert rather than just looking at that activity directly and having to kind of filter through all of those things. All right, and then for privilege escalation, again, this is typically what we see and what we have seen is that if the initial permissions attached to the identity that is compromised don't give the adversary the access that they want, they might attempt to attach an additional policy that does have those permissions. So you can add additional filters here for policy names. If you're looking for admin or super or power, you can kind of add additional granularity there, depending on the naming convention within your organization. All right, then for persistence, there are a number here, just kind of covering, a lot of them are the same, but it is duplicated across, whether you're trying to create or modify a role, user, it just depends on the identity type. But there is a number of different API calls here that we've seen that actors leverage for persistence. All right. And then for exfiltration, kind of like I was saying, the most common API call that we see at the control plane level for exfiltration is S3 get object, because that is at the control plane. But there are a number of different ways, again, that data can be exfiltrated. So, if we're looking at potentially, say, a web application compromise, those requests might come legitimately, or the request would be legitimate, the access would not be, through the application. And so you might identify requests that were being made to the application, and then potentially a query to actually pull information back from the database. Or if there was some sort of successful password spraying attack against a number of different accounts, you might see requests from a number of different identities to the application. And so you might not necessarily see anything at the control plane level, any sort of compromise of the control plane level if it was a web application compromise, whether that access was through valid credentials or some sort of vulnerability in the application itself. Control plane, if, again, that's what we've been talking about. If there is some sort of access to the control plane or to an identity, then you can access those resources directly. You can potentially make those resources publicly available so they can be accessed. They can be shared with another attacker managed account, a number of different options there. And then for an endpoint, if there is some sort of pipeline or other process that's set up where a threat actor has access to an endpoint that has credentials on that system, they might be able to access your applications through, say, a developer's means of access or via a separate API specifically for the application. And so those requests and exfiltration data points are not necessarily, again, going to be at the control plane level. That'll really just depend on the actual application and how it's all set up. All right, so like I said, each of your organizations, each of your security stacks, each of your infrastructures are going to be different. You all are going to know your environment better than somebody else will. And so, kind of taking these data points and kind of like understanding the mindset of, if something anomalous or malicious happens in your environment, making sure that you have that trip line, that you have a method of actually detecting that activity, and then making sure that there is an actual pipeline so that those detections, those alerts don't just stay within that singular console. I know you all have a number of different tools that you're working with. I know logs are forwarded to different places. It can be sort of overwhelming, but just take a moment, to kind of review the process and the forwarding of those alerts to make sure that you actually would have visibility into them if something happened. You might have security tools already in your stack that that gives you good detections, that gives you high fidelity alerts for activity. But again, if that's not being forwarded somewhere else, if it's not in front of a security team, it might not be reviewed until it's too late, and you've now got a third-party notification that a database was posted somewhere, and you're going back and doing an investigation and saying, hey, this actually was in here the whole time. We just didn't have the pipeline to actually forward those alerts somewhere. Knowing your adversary and knowing what your key targets is also very important. Again, you know your environment better than an adversary, at least initially, right? And so understanding what those key targets are within your environment, understanding which databases might have sensitive information, and then making sure that you have visibility into those resources, that if something anomalous happened to that resource, you would know about it. And then obviously, reducing your attack surface in the first place, making sure that you don't have privileged permanent credentials that can be compromised and then leveraged for access to an environment and then potentially lead to exfiltration. Reducing that attack surface as much as possible is important because it makes it, again, that much harder for an adversary to achieve their objectives and gives you more opportunities for detection if they have to jump through different hoops. And then monitoring your attack surface. That's what we've been talking about, this whole time. Making sure you do have visibility into your environment. Again, you can't protect what you don't know about. We've had a number of investigations, where there was infrastructure that was compromised, but it was actually from, a company that was acquired. And so their security posture of that particular account was not the same as the baseline for all of the other accounts because it was acquired, and then the logging retention, the security controls, the SCPs, all of those things were not necessarily updated to match the security posture for the rest of the organization. And so we go to do the investigation. They're like, well, this shouldn't have been possible. This shouldn't have been possible. But again, it was an account that was acquired and the security posture didn't match. So having visibility into your environment is obviously a key part here. All right.
Thank you. Just to reiterate something that you just mentioned, when the attacker's in your environment and they're looking around because their hands on keyboard, they're not going to go after the best protected resource. They're going to find the least protected resource, the one that you've forgotten about, like the one that you deployed in a test environment, or that old system that's too old to support whatever your security tool is. That's where they're gonna hit first. So, one of the themes here is knowing your environment, getting eyes in the environment, collecting the right data. In this case, since when we talk about sophisticated attacks, we're really talking about cross-domain, multi-domain attacks where an attack might jump from a developer's laptop. They're working from home, but they have stored keys in order to run API commands inside of their cloud environment. That's going to be a target. And then that's a way for them to jump into the cloud environment. And they might work inside of an EC2 instance, and then they might move around and only insight about an identity-based attack is going to help you tie all the different pieces together. So in the Falcon platform, what we go after is focusing on those core domains that provide the best information to let us know that there's an attack in progress. And the key domains that we're looking at data for is EDR, endpoint detection and response, which is more than just your laptops. It's really any runtime environment where we can see everything that's happening in that runtime environment. Those subtle, potentially subtle indicators of attack that taken in isolation don't really look like anything's happening, but when you look at the sequence of events, that's when you can see that there's an actual attack in progress. ITDR, Identity Threat Detection and Response, again, when you're talking about protecting your runtime environment, and we recommend you want to have as much visibility across your environment as possible, deploy sensors on every runtime environment. But what cuts across all those environments is your identity infrastructure, where that central repository of security principles is being used throughout the environment and enables your security investigators to track the movement of an attack across your environment. And then, finally, the other main domain is cloud security. Cloud security is very complex. In AWS, 200 plus services. You have managed services where you only have API access. Your runtime environments in EC2, container environments, Lambda. Your identity, your pre-runtime infrastructure as code, all of that needs to be protected, and all of that is a source of telemetry to aid in an investigation and detections. Just looking at Falcon Cloud Security, these are the things that I was just mentioning, where you can really dive down into your security posture management, so that where we're talking about reducing your attack surface, that cloud security posture management gives you the insight to figure out where you can start reducing that attack surface. And I think one of the things that really hit home for me in your talk, Mariah, was there's some areas that are especially important to tighten. Obviously, identity, least privilege, but there's a number of areas that you really want to make sure that you shrink that attack surface down as much as possible. The workloads themselves, the runtime environments where the attacker could be actually leveraging your compute to advance the attack. Your application environment, you move from a monolith into microservices, and now the attack surface has now exploded, where your dev team is maybe doing multiple releases a day. Each time they do a release is a potential for security regression. Application security posture management is able to stay on top of that and dynamically see any new risks that have been surfaced in the latest deployment. Data security, where's your data, who's accessing it, where is it moving? All of this, cloud security, Falcon Cloud Security, is able to give you those insights across all of those different domains. Now, when you take all that information, okay, if I haven't overwhelmed you already with just a wide variety of information that we're taking in, now you got to take all of that massive amount of information and shrink it down, so you pull out the signal from this massive amount of noise and figure out, what could be the next zero-day attack. If it's an existing attack that we know about, we can identify it in the moment and block it. But do you know the number of how many new 0 days we detect? I think it's something crazy, like 200 new 0 days a day or something like that. But it's a lot, and so you never know exactly what's happening. So we have our threat hunting team, Overwatch, that's looking at all of this telemetry 24/7, 365 to figure out where the next 0 day is coming from. And they're able to crunch together all of this cross-domain information to let you know if something's happening. And again, this idea of can it all be automated? No, because there's this element of creativity where our threat hunters are experienced security professionals. They can take that refined information, look at it and say, is this the new indicator? I don't really understand what's happening here. They continue to investigate until they figure out, something is happening here. we've just discovered a new sequence of behaviors that is indicative of a new kind of attack, then we take that sequence of behaviors and we actually bake that back into the product. This is the ongoing process for what makes CrowdStrike effective, where we have our human investigators, our incident responders, our threat hunters, our intelligence analysts who are taking all that information and figuring out this is the new attack. Then we build it into the sensor so the sensor can see it happening in the moment and block those attacks. You mentioned before, know your adversary. Our Falcon intelligence team, all they focus on is tracking adversaries. I think we're tracking about almost 250 specific adversaries. We understand their motivations, and they have their own tools, tactics, and procedures. They're working off of a run book. So when we see a certain sequence of behaviors, we're like, okay, we know who that adversary is, and we can often anticipate the next thing they're going to do. Then the sensor sees that this next thing happened. We're like, okay, that's an attack, block it. Now, going back to the image we saw before, where the attack was able to continue, the Discover tool was blocked, the adversary opened the console, they were able to move laterally before the SOC analyst even received the ticket. Now, when you have Overwatch, Falcon Overwatch, our threat hunting service, engaged, now what happens is that same action, the Discover tool's blocked, that next action open console is something that the Overwatch team sees. Every specific thing, that LSAS dump. Now, these specific indicators of attack are something that's familiar to the team. It's information that we're collecting through the sensor, and we're correlating information from our identity protection, and the Overwatch team is able to say, okay, that looks like an attack. And Overwatch will now alert in the console, so now the security team at the customer that had no idea all this stuff was happening, now they have an alert. They see the alert came from Overwatch. When an alert comes in from Overwatch, take a look at it. Like, Overwatch team is not just giving your security team more stuff to do. They're sorting through all this and saying, okay, you've got a problem, you need to take care of this. So in this particular scenario, the customer isolated the impacted accounts and workloads in 40 minutes. So before that lateral movement time. Now, pivoting a little bit, again, in the cloud, you're building your infrastructure with infrastructure as code. You have auto-scaling capabilities. You are dynamically deploying new resources in response to increased volume and utilization, scaling back in when that subsides. So if all this is happening programmatically, are you sure that your security controls are being uniformly applied? So what we have done is part of our ongoing project of integrating with as many AWS services and processes as possible. We have a portfolio of automated deployment mechanisms that take advantage of the event-driven nature of the cloud control plane. So our CSPM, Cloud Security Posture Management, that gives you that view of misconfigurations in your cloud environment, or subtle indicators of attack represented by some of these suspicious API control plane commands. That registration into the Falcon platform, where we're able to provide that insight, all that's happening in the background. Add a new region, add a new account, that account gets automatically deployed, if you are using our deployment mechanisms. The one that we're looking at here rolls all of these three mechanisms together in something called AWS Built-in, which is a program run by AWS, the security reference architecture team, that operates in a multi-account environment to help dynamically deploy our product alongside AWS services. So the one here, we have a SSM distributor package. If you're deploying the sensor on your EC2 instances, you can use the distributor package to create an automation that will deploy the sensor to every new EC2 instance as it's launched. And finally, our container protection, we use Kubernetes native objects like daemon sets so that every new EC2 worker node that's deployed automatically gets a Falcon sensor pod that scans all the containers on that EC2 instance as well as the instance as a whole, and also is looking at the overall configuration of the Kubernetes environment. You could write policy on it that can block the deployment of vulnerable container images and misconfigured container images with elevated permissions and so on. So you can use these separately, or again, you can deploy all of them together using AWS built-in. I mentioned before our ongoing product of integrations with AWS services. Our intent is to help make your cloud journey safe. So we utilize the foundational services of AWS. CloudTrail, you know, CloudTrail's amazing, right? Everything that happens on the control plane is getting logged by CloudTrail, and it gives you an incredible richness of information. If you wait for that data to write to S3, now you're waiting 10 or 15 minutes. So in our architecture, we're pulling that through EventBridge before it's even written to S3, so we're able to see those potential indicators of attack in near real time to help you move fast and see what's happening in the moment. So deployment mechanisms, I mentioned EventBridge, CloudFormation ABIs written in CloudFormation, Code Pipeline. You can use Code Pipeline to automate container image scanning in your dev pipeline. You could use it to, to deploy the Falcon sensor in your EKS environments, and we're using Code Pipeline, Code Build for the EKS protection. Runtime protection. How many different services are actually running an operating system in the background? Your container services, EC2, workspaces, outposts, all of those we can protect. Cloud security posture management. We have a long list of services that we're looking at, that control plane activity and misconfigurations. We've recently also added SageMaker and Bedrock to that list of CSPM protected services. And finally, you're able to pull Falcon data into AWS if you're using AWS for log analytics, building your own SIEM, and so on. You can pull data into Security Lake. We can pull down into the Falcon NG SIEM. You can pull data down from Security Lake, Security Hub, GuardDuty, WAF, CloudTrail, CloudWatch, and other services. So no matter where you're running your SIEM, where you're doing your investigation, you can send your data where you need it. And finally, if you want to take some next steps, you can learn more, you can get hands-on, you could start a trial. I invite you to take a picture of this, and you can parse through those QR codes later on. One of the items here, Charlotte AI demos. Charlotte AI is our generative AI security assistant. I've thrown a lot of information at you. There's a lot of capabilities in the platform. How to get your arms around all of it. You could ask Charlotte AI. We'll take an investigation that could take a human moving through our console. And our console is very efficient. It's built for security investigators, but it still takes time to follow the trail. Charlotte AI will do it in seconds. So you can see some of those demos there, some NG SIEM demos if you'd like to learn about them. There's a great hands-on cloud security lab that we have published to AWS workshops. And if you're not sure about your cloud security, we invite you to take do a cloud security health check. We'll give you $1,000 of service credit just for going through our cloud security posture management assessment. So that's all I have. Thank you very much. Please do the survey. Thank you.